Hello guys, this is Mr. Quantum. I'm a theoretical physicist. I'm going to have for you physics lessons from basic level to advanced level. In this way, to make you completely understand the deep concepts of physics, I'm taking many examples. I'm also doing it interactively. So you can pause videos and then solve the example. Then I will solve it for you, of course. In this first lesson, I'm going to talk about the dimensions in physics. So, and also scalars and vectors. So, this is a very basic lesson and video for physics. Be with me. About the dimensions in physics, as you know, we are working in physics with SI system, which is international system. And in this system, we have some dimensions for some quantities. For example, for length, we have, when I put this square bracket around the quantity like this, I'm going to show its dimension. So, for example, for length, it is a meter. And I would show length in my equations as L. For example, I'm going to say 2 meter or I don't know 3 meters. The other quantity is mass, which is important in the future lessons, and in SI it is kilogram. Its dimension is kilogram, and I would show it with m in my equations. I would say, for example, a person weight is actually 70 kilogram in average, let's say. The other quantity is time. I'm going to show its dimension with second. For example, I would say, I don't know, a process would take, for example, 2 seconds, 3 seconds. And in our equation, I would show time as a variable with t. So, these are three important quantities and their dimensions. Other thing that I'm going to talk about in this session is actually vectors and scalars. What is a vector? What is a scalar? Let me tell you about a scalar. A scalar actually is a quantity which has just a magnitude. For example, mass of an object. Let's say, for example, I have an object here. It has a mass, and its mass is 2 kilogram, for example. This 2 kilogram is a scalar. It's an scalar quantity. It means that we have just the magnitude of it. That's it. But when I compare it with a vector, you will understand what does it mean. But a vector is actually uh, it has two parameter, let's say, a magnitude and also a direction. So, for example, when I have when I have, for example, diagram like this, and for example, it is x direction, this is y direction, and this is, for example, I don't know my scale on it. Huh? This is 1, 2, 3 in y direction. This is 1, 2, 3 in x direction. So, for example, I want to connect this point 1, 1 to, let's say, this point. This is my vector. So this vector, as you can see, it has a direction and also it has a magnitude, which is L. And the magnitude of a vector will be actually calculated as root square of um, xf, which is the final point in x direction, minus xi, which is the initial point in the x direction, to the power 2 plus yf minus yi squared. Root square of these two plus each other. For example, here in this example we have, it is actually root square of uh, xf. Here it is 3, as you can see the final point on x direction is 3, minus xi, which is 1, so it is 2, so 3 minus 1 squared plus yf is 2 minus 1, again squared. So it becomes 4 plus 1, which means root square of 5. I must be, for example, 2 point something. So I want to wrap up our session. We've learned about dimensions in SI system, which is length, mass, which is kilogram, and also time, its dimension is second. And also we learned about the scalar and vector. The scalar has just a magnitude, and vector has got two parameters as magnitude and also direction of this. You will see many examples of these in next sessions.